This chapter starts off by solving linear systems. There are going to be 3 different ways we learn how to solve them. The first one is going to be graphing. Before we learn how to solve, let's learn what a linear system is. So, a system of linear equations is 2 or more equations with the same variable. So I'm going to put that here. Notice the title of this says linear systems, and then this says system of linear equations. It means the same thing. So 2 or more equations with the same variables. Here's an example. X plus 2y equals 7, and 3x minus 2y equals 5. A system of linear equations is 2 or more equations with the same variables. So here we have 2 equations that have the same variables. To solve this, the solution is going to be an ordered pair. An x and an y. Again, there are going to be 3 different ways to solve a system of linear equations or a linear system. The first way we're going to learn is by graphing. So what's going to happen is we're going to graph both equations on the same coordinate plane, and we're going to check to see where they intersect. Wherever they intersect, that's going to give you an ordered pair, an x and a y. That's going to be your answer. So let's give this a try. Let's say we have negative x plus y equals 5, and the other equation is 2x plus y equals 8. Our job is going to be to graph both of these equations. So I'm going to put up here, step 1. Graph. To graph an equation, you're going to want to make sure it's in slope-intercept form. That means you're going to have an M and a B. Okay, so over here I'm going to split these 2 equations. The first one is negative x plus y equals 5. I'm going to put it in slope-intercept form. I'm going to get y by itself, so I'm going to bring x to the other side. I get y equals x plus 5. The other equation I'm going to do in green. Again, my goal is to get y by itself, so I have a slope and a y-intercept. To get y by itself, I'm going to move 2x to the other side. These are not like variables, so I'm not going to combine them, but I'm going to put the x term first. Now that I have them in slope-intercept form, I can identify their slope and their y-intercept. I can do the same with the other equation. And I can graph. This says that my y-intercept is 8, or sorry, my y-intercept is 8 and 5, so I'm going to have a tall graph. Okay. So I'm going to graph the red equation first. The y-intercept is 5. 1, 2, 3, 4, 5. And it tells me to go up 1 over 1. Now when you're drawing these equations, you're going to want to draw multiple ordered pairs. And you're going to want to use a straight edge. If you don't, it's going to be harder to find where the lines intersect. Same with, I know you're in your notes, you're not using grid paper, but on your homework you're going to have to. Okay, now I'm going to graph the second equation. My slope goes down 2 to the right 1. Use a straight edge. Okay. Both equations are graphed. I'm going to put a step 2 up here. I'm going to add to my list. Your solution is where the 2 lines intersect. Your solution is where the ordered pair where the 2 lines So right here is where the two lines intersect. That ordered pair is 1, 1, 2, 3, 4, 5, 6. This is our answer, right here. But you're going to want to check to see if that's the right answer. So this is going to be step 3. Check solution in both equations. Okay, so even though I have my circled answer, I'm going to plug them back into the original equations to check to make sure they're true. The reason you're going to want to do this is because this is not the most efficient way to find the answer to a linear system. Sometimes you might draw sloppy, or if you're not using graph paper, it's going to be really hard to find that ordered pair. Alright, so I'm going to plug them back into the originals. Here are my originals. I'm going to do it over here. So my x is 1 and my y is 6. Negative 1 plus 6 equals 5. Well, negative 1 plus 6 is 5. So that's true. I'm going to plug it into the other one. 2 times 1 plus 6 equals 8. Well, 2 times 1 is 2. 2 plus 6 is 8. So that's also true. Because both equations are true with that ordered pair, that must be our answer. Okay. Here's another one. Negative 5x plus y equals 0. The other equation, 5x plus y equals 10. Push pause and try that now. What you're going to do is you're going to graph both equations. To graph both equations, you need to have them in slope-intercept form. So I want y by itself. I could put 5x plus 0, but this means the same thing. Here my slope is 5, and my y-intercept is 0. The other equation also needs to be in standard or slope-intercept form. So I get y equals negative 5x plus 10. If you have 10 minus 5x, that means the same thing. Our slope is negative 5, and our y-intercept is 10. This looks like it's going to be another tall graph, because our y-intercept is 10. Start with the red equation. We start at 0 on the y-intercept, and our slope is up 5 to the right 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Using that straight edge always. The other equation, start at positive 10, which is right here, and go down 5 to the right 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Your solution was where the two lines intersect. Our two lines intersect at 1, 5. I'm going to check to make sure that's correct by plugging them back into the original equation. Again, I'm going to do that over here. This is my x value, this is my y value. Negative 5 times 1 plus 5 equals 0. Well, this is negative 5. Negative 5 plus 0 is 0. So that's true. 5 times 1 plus 5 equals 10. 5 plus 5 does equal 10. So this must be the solution. That's the correct answer. Okay. I want you to try this one on your own.
Pardon the interruption. We will need 2 additional teachers at all lunch recesses today. Thank you.
X minus y equals 5. 3x plus y equals 3. Push pause and try that now. Okay. We're also going to do a word problem together. We're going to have to write an equation and then graph them to find the ordered pair solution. Your school is selling football tickets for a home game. The school sold 25 tickets for $60 on the first day of the sale. Student tickets cost $2 each and non-student tickets cost $3 each. Find the number of student tickets and the number of non-student tickets the school sold. Okay. This lesson is on the system of linear equations. You're going to need two equations. One equation is going to strictly deal with tickets. The other equation is going to deal with the money involved with the tickets. I'm going to assign two variables. I'm going to use X to represent the student tickets. And I'm going to use Y for non-student. It says that the school sold 25 tickets total. So the student plus the non-student tickets equals 25. That's going to be my first equation. The student tickets plus the non-student tickets equals 25 altogether. That strictly deals with just tickets. Our next equation is going to deal with the costs. Student tickets are $2. So 2 times the number of student tickets. $3 is the non-student tickets. 3 times the non-student equals a total of $60. So again, I have one equation that just deals with tickets. The other one deals with money. I have a system of linear equations, so now I can try to find an ordered pair. To do that, I'm going to graph. To graph, I need to put both equations in slope-intercept form. So I get y equals negative x plus 25. The other equation, bring 2x over. I get 3y equals a negative 2x plus 60. And divide both sides by 3. Okay, divide both terms by 3 on the right side. This doesn't come out evenly, so I leave it a fraction. 60 divided by 3 is 20. Now I have an M and I have a B, so I can graph. Okay. Now we're dealing with the real world, the number of tickets. So think about what quadrant this is going to be in. This is only going to be in the first quadrant because we can't have a negative amount of tickets. With that being said, I'm still going to use my median grid, so hopefully we can see it. When I make my coordinate plane this time, again, I'm only going to use the first quadrant. Okay, let's label these a little bit. This is 2. Yeah, see, I'm still not going to have enough room. Let's see if I pull it down a little bit, if it'll work. 2, 4, 6. When you're graphing, you're going to want to try your best not to go up by 2s. I know it looks like I am, but each line is represented here. Here we go. This should work. Okay. All right. Let's see if we can get this to work. Our first equation, the y-intercept is 25. So that's here's 24. This is 25 right here. And our slope tells us to go down 1 to the right 1. Again, you're going to want to draw as many ordered pairs as possible, and then use the straight edge so you can see where the lines intersect. Okay, so there's our first line. The second equation starts at 20 and goes down 2 to the right 3. So here's 20, down 2 to the right 3, down 2 to the right 3. Oh, I can see where it intersects. That's good. And it should be enough information to draw a line. Okay, so I'm going to look at that plane of intersection. I didn't label these down here. 2, 4, 6, 8, 10, 12, 14. It looks like this is 15. And then the y is 10. Okay, so we got our solution. There it is. 1510, what does that even mean? Well, let's go back to the original problem. It said that X stands for, or we said, X stands for student tickets and Y stands for non-student tickets, and that's going to work for the ordered pair as well. The X's are students, and Y value are our non-students. So if you were to do a word problem, you want to make sure that you label those. 15 students and 10 non-student tickets were sold during school. I hope that more people went to the football game, but I'm going to assume this is just during school hours.